So we have global presence across the world. So it's like a $2 billion+ company. So in Malaysia itself, we have two branches in Penang and Malaysia, and we have projects with major Fortune 500 companies. So when it comes to semiconductors, so we have various verticals in the company. So semiconductor is a big vertical, one among it. So we work with the top 10 semiconductor companies, you name it, Intel, AMD, Infineon, and Microsoft and things like that. So I just will run over on this. So what are the programs that we have when it comes to our UST framework? What are the programs we're engaged with government and the universities, and what are the product enablement that we do, and how we have been transforming Malaysia in terms of leading digital economy, and so some of the activities that we do when it comes to Step It Up, engaging with universities and employment activities, and we collaborate with various universities, including UTM and USM and all that. So I'll just go quickly because to go directly to the topic that we would want to go, but I just want to make sure the audience has an understanding about the company that I come from. So these are various activities that we do. So there is the email ID that you can contact, hiresh.apac@ust.com. So that was a very short introduction about the UST because I want to focus on this topic. So coming to the semiconductor capabilities, so in coming from the perspective of a service company, UST, so these are the areas that we have projects right now that's happening. So as you see, it's end to end, right from pre-silicon, post-silicon, and then supporting once the product comes out, right? So right from architecture definition, RTL, synthesis, platform validation, then ATE, driver development. So you take any product, let's say you are buying some Xbox or some GPU. So it all starts from the architecture. Then slowly your product comes into life, and once the product is in your hand, you do the testing and make sure it works in software perspective. Then give the support. So UST is there in all this area, and these are the opportunities right now we have in UST. And so I'll pass this deck to ASM later. You can have it. So what is the typical recruitment process? And so this is a short introduction, all right. So then these are some of the certifications that we have got as UST here across the globe, including Malaysia. And these are some of the capabilities, semiconductor perspective. What are the pre-silicon solutions that we have, and our team strength, and the R&D team that we have. As you see, he is the site leader of UST Malaysia. So he was also recognized by the government for his contribution in generating employment. And yeah, so these are some of the events that UST organizes. So this also we have presence across the state. And these are some glimpse about the activities that recently that we were engaged with. And yeah, so it's not just semiconductor. We have various other vertical also, SaaS and AI and data services and GBS. So it's a large organization. So I believe that was a very fast, quick introduction about UST. So now let's go to this specific topic that is given to me. So how do you become one? All right. So anytime feel free to ping me. So I myself, my name is Kotar Badusha. So I'm a solutions architect. So basically, I have to give solutions for semiconductor industry from the perspective of automation and AI. All right. So 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 what do I do exactly is that, so in semiconductor industry we have various stages. So right from pre-silicon, post-silicon, that as we see. So we have to come up with solution to make it automated, right? So whether it is FPGA based or ASIC based, and then you design the test for the platform, DFT or AT, SLT. So in every phase, there are areas where there are manual processes involved. You want to make it automated and regression and all that. So that involves a complete understanding of the particular phase. So my focus is on automation in IC design and testing and support, as well as recent 3 years has been more focused on the AI perspective. So which is where here it is. So for the past 19 years, the focus on semiconductor industry, focusing on automation, AI, that affects every stage. So my current role has been in establishing the engineering solutions globally, and the SME globally for that. And APAC area, I focus more on embracing AI. So I have done extensive work with various Fortune 500 semiconductor companies. So on high-speed memories and GPUs and system-on-chip device. So I don't just design chips. So I also have to build the software and automation architectures. So that ensures those chips work when they come out of the fab. So that's an introduction about myself, what I've been doing for the past 19 years. So then why Malaysia and why now, right? So interestingly, as we have seen, Malaysia has played a great role when it comes to post-silicon in the past decade. And and it's good that we are seeing that it's growing in the value chain in the other end as well, which is where we see is transitioning from made in Malaysia to made by Malaysia. So we can't do that until and unless we capture on the IC design perspective. And unique thing about in Malaysia is when I design a chip, I can test it in simulation as well as I can test it in real life. So there are very few countries where you can do that, right? Because there are some countries they're good in design, but they don't have any OSAT or wafer sort, the actual factories, because it's very hard to build them. Or some countries they are very good in OSAT, but they don't have the knowledge capital to do the design. So Malaysia is in a unique place where you can design, I can test it simulation, I can quickly go to the factory. So that iteration loop is something reducing. So it's a good opportunity now, and especially the establishment of Malaysia Semiconductor IC Design Parks in Puchong as well as in Cyberjaya by SIDAC has been having a significant impact. We see the amount of talent that we get now was not so easy before. So the interest given by the students and we search for profiles, we are very glad that now we get in Selangor itself. And the talent drive, especially the ASM's proactive initiative to train thousands of engineers through programs like ChipStart, is directly addressing the talent shortages that we have. We can see in the upcoming slides practically what are the areas that we are looking for, right? So, in summary, we are entering the market at the exact right time, like now before. So, one of the angles that I would want to bring in is uh, practically making design with respect to ROI is making sure there is testability involved. So what I exactly mean is a good IC designer in my career have seen is not working in silo or isolated. So he makes sure he understands end to end from system perspective, and whatever IP he has designed is testable, both in simulation as well as in real world. Like one of it is, as you know, for example, design for testability. Similarly, there is this design for manufacturing where you design such a way that even there is deviation in manufacturing, your buffer still holds good, right? So one of the design stream is design for testability. I would want the engineers to encourage to have a look at it, especially considering Malaysia, it has a very good niche area to fit in. As I said, we have both factories here with design, so this DFT would be a good bridge there. And some of the lessons, like if you when you're designing complex system on chips, but if you ignore this testabilities like good JTAG IPs or scan or thermal diodes to pick up the temperature, the product will fail in production. Because recently we are in these days of AI and high speed and stacking and UCIe. So where the proof points are very important. So that's what this diagram is trying to show you how complex a chip might be, but we still can probe out the failures. So next on the current market requirements and what the industry demands. So it's very hard to predict the market for let's say for 10 years, but for sure the near 5 years, the top demand seems to be it's very clear, which is it's driven by AI, so which requires high bandwidth memory and fast interconnects. So when we say high bandwidth memory, if you apply first principles, you need to be very good in understanding the high-speed circuits, data exchange, and high-speed protocols. One of it is naturally is PCI. So when I began my career, it was PCI Gen 3. So I got certified in Colorado Institute, and now we have PCI Gen 6. So things are going very fast, and of course memory. So when I began, it was like asynchronous SRAM and DRAM and all that. But now we have various other technologies also coming by, including powerful ROMs are coming, and as well as HBMs for the GPUs, right? And GPUs. And beyond all this, thermal management, because until we see the quantum and optronics coming by, the reality is we have to still manage the power requirement. So thermal management is also an area that is huge demand. So this is coming about the IPs where you want to focus. So you start from the basics to make sure you're good in at least one high protocol like PCIe, and then I do some processes like thermal management. When it comes to tooling ecosystem at a high level, what we notice is that every year the hardware engineering is now very much software dependent. That is, of course, you need to know the EDA tools, but who is focusing to make sure your chip is testable? It's good to get exposed to tools like Advantest or Teradyne, because when you are generating the vectors for scan and tests like that, your exposure to such tools will easily bridge the Malaysia's market requirement. And then scripting is mandatory. What I mean is, gone are the days when you could just copy paste and get along the manual days, because now the timelines are getting very tighter, things are getting complex, and you have to sometimes migrate from one generation to another generation. So proficiency in good scripting language is essential, as essential as you use PowerPoint or Excel. So similarly, like be it Python, Perl, or C++, is no longer optional. It has to be known, apart from the core language that you're using for your IC design perspective. So far so good. Any response? Any input team so far? I can't. Hello. Hello team. Can you hear me, or any reaction you can give?
Well, they can give reaction, but they can't open mic, so they will only can
Oh,
reaction.
oh, some kind of emoji reaction. Okay, okay, it's okay. Yeah, because from my side it's just silent, so I'm assuming everyone can listen. All right. So now let me go to the system thinking perspective. So we began from, what I do and why Malaysia is some side we saw, and my perspective, my individual perspective from my career on the importance of designing such that it is testable is a very good skill and applies mostly in Malaysia, especially is what my understanding is. Now let's go to the system thinking perspective. So system thinking is basically like you would have seen like big malls or say some big apartments. If you really apply system thinking, though it looks very complex and large, there are some areas if you break it down like a Lego block. At the end of the day, there are some first principles that is involved, right? So as long as you know, okay, let's say you know how well the structure has to be for a good wall or a maybe good hall or maybe good reading room. If you really master that skill, there are chances that you can easily pick it up how to scale and build a big apartment, right? In the same way, do not underestimate whatever working, and do not underestimate our fundamentals textbook as well. So every week there are situations where I go back to the fundamentals and double check. So if you are working on some noise, you still need to read the parasitics. You need to know the transmission load. You need to know the noise margin. So the fundamentals always matter, and then that you have to apply at a system level perspective, right? So though they are complex, system thinking still helps on that regard. So in that sense, your understanding lifts up. So you would have started in your colleges from valence bond and how electrons behave. Then you go up to maybe junction voltage and diodes, and you keep increasing the layer of understanding, right? Then you go to maybe transistors, then inverters, then AND gate, then ALU. So the level of realization keeps increasing. So in the same way, as long as you apply that perspective, it becomes seamless in designing the system. And also, you need to understand the yield concepts as well. When you are a good engineer, when it comes to the local APAC market perspective, why I say is that when you design it, you have to be cautious about the corners. Is it fast pass? Is it slow? These are basically the NPN characteristic of the transistor, how it impacts whether it is a fast silicon or slow silicon. If so, you can design in such a way that it produces the best yield. So this seeing this whole picture is a very niche talent, and that is something sought out in the market, where companies are willing to pay more if you can understand how your design is going to impact in system perspective, right? So that's the thing. And so far we saw what is specific about an IP and market and tools, and you know, there are some things I see is that which has a long shelf life. Like for example, you would have learned about some say vacuum tube, but today there's no vacuum tube. So you would have studied, become the expert of floppy disk. Floppy disk is not there, right? Or you would have studied about hard disk. Nowadays it's all SSD. Hard disk is still there, but for archiving. So if you notice, every 5 year or 10 year or so, there are some technology or IPs that might just vanish. So we have to accept that. So in that case, you have to anchor on a long-lasting IP or anchor on a long-lasting principle, right? So some of the principles that I notice is, as you saw in the previous slide, always master the fundamentals. So there would have been, we are witnessing this AI and all this explosion, but still fundamentals still matter, right? So tools can change, computer architecture can change, but your methodology still remains the same. Everything still has to respect the fundamental laws, right? No matter what we design a ship or an aeroplane, there are some fundamental laws it cannot go against. The laws of physics and the same way, when it comes to our VLSI, you still need to be very good in those fundamental principles when it comes to analyzing the issues and debugging. And then the second thing is be very agile. What I mean is, do not be very restrictive that I will be in only this particular technology and this only. I will not even waste my time in other area, because the market is very dynamic. And in my career itself, although I plan, sometimes I am very flexible, right? So I began in some areas and have I managed to get opportunity in multiple areas which I would have never thought of. So the good thing that I did was, when opportunities come, I see is it really fitting me, and try to always be flexible, right? And when it comes to your design, have a test-driven development, like as we saw in the DFT perspective. And if you're developing some flow, you have embrace this continuous integration where your flow can be checked in real time in acceptance test program, let's say a chip mock test that is being driven by the engine, and standardized frameworks, so that you can easily migrate from one framework to another framework. And the recent 2 3 years that we are seeing is the generative AI, which is reshaping our industry. So as you have seen, popular EDA tools are providing this Gen AI plugins where I can just interactively say, hey, can you check my transistor? Is it running fine? Or can you generate the Monte Carlo plot? So the tools have come where it relieves this mundane work earlier, where engineers have to manually go to a particular directory and run it. So knowing how to use this is something essential now, like every day how we use Excel or PowerPoint. So every day using it will give an insight which tool is good in what. And implementing AI tools for business will set you apart. So your exposure as well as how to implement that in your organization will something help you in the career, and you'll be standing out in the organization. Yeah. So that was a short introduction about the company, myself, and my inputs on how to be the one. And for the next steps, as we see here, do not just study theory. You write code, simulate design, and write test benches. That is, companies don't just see your resume. Even if you don't have work experience, go to GitHub. There are many open source design frameworks where you can design your own chip. There are some even foundries that can freely fabricate your chip as well. And so that's a good chance that we have now. And leverage institutes like ASM. They are really there to build your portfolio and connect with industry partners. So when we get a resume or profile from ASM, it has more value, we see. And embrace the debug process. So the best engineers are the ones who can perform deep root cause analysis when things break. So when you are doing your own hobby project, the time where you getting stuck is not frustrating. That's where you learn. So if it was really working at the first time, that's not a good news when you're learning. So whenever you're feeling stuck, that's the place where you understand about the tools and you understand the fundamentals. So you really have to embrace the pain earlier to grow in the career. Yeah. So with this, I think I'm done with the short introduction about this topic. So anyone has any questions, students? Hello, hello, Louise. Is some team or anyone?
Hello.
Yep.
So it's actually there is a question inside the chat box.
Oh, okay.
Yeah. So there are very less openings for Freshers India for front end role.
Mm-hmm.
So he asked about this.
Let me. I'm trying to access the chat box.
Oh yeah. I can read the questions. You can.
Sure, sure. That will be
Yeah.
fine. Okay.
Okay.
All right.
So there is a first question, like what challenge for companies USD handling supply chain in global geopolitical issue?
Uh, so UST, of course, is a American company, and I mean we try to keep away from all those politics. So, but still we follow the rules that is there. So in this case, in Malaysia, of course, Malaysian rules, and globally when it comes to there are some global MSAs and NDAs. So yeah, that is something I'm not the right person to comment about that. But as I said, regardless of geopolitics, there are some technology that impacts every country. And recently, as you see, everywhere is this automotive and AI and energy sector. There is a huge demand because everything is interrelated. Because of people moving away from oil, so in electric, and now intelligence has become a general commodity, almost impact the GDP of country. It affects every sector. So AI is growing like as you see every quarter, you see new frameworks and new tools getting displaced, and of course power area energy. So I think that's the place we need to be focusing to guard ourselves. I'm not sure if I really answered on your geopolitical thing. So we are focusing on area where we are safer.
Okay, there's another question regarding VSLI, how to apply. Like theory vs actual more better.
I'm assuming it is VLSI. I believe it's a typo.
Mhm.
So the email ID to apply for UST, I would share it to ASM. You can apply. As I said, both are important. Theory is also important. Practical hands-on is also important. So theory is where you have that research-oriented mindset where you understand the concept without any computers, right? You can imagine what's happening, right? And so theory is very important. But actually, is because if you cannot apply it, it's, like theoretical physics and applied physics, if you cannot build a rocket or gun or something, right? The same way your theoretical knowledge has to be applied. So which is why I gave suggestion. Recent few years, doing open source designs have been easily available. For example, Malaysia engaging with ARM and all that exposes us to the risk-based design, which is catching up. And compared to CISC risk, there are a lot of freely available frameworks. So in your home, you can design. So you can imagine like this. Let's say you're searching for a job, maybe to become a singer, then people would see, okay, how you are singing in YouTube or TikTok, right? In the same way, if I'm looking for a designer, if someone has his example designs available in his GitHub, that adds more value. Yeah.
Okay, we have another question as well. There are very less opening for freshers in India for front end role. So what industry is looking for the skill?
Front end role in which area? Can you repeat if you don't?
Oh, this front end role.
Mhm. So we still have openings, as I said, no. We have to see it's a case to case basis. You have to see the resume. You have to see if there is any experience. Yeah, based on that. Maybe you can send your profile and we can have a look.
So another one, how has AI helped in the chip manufacturing sector? We always hear about chip being used to implement AI, but how
Mhm.
can we use to better help us design a better chip?
Okay, so as I said, no, I do 50% of my work now in AI. When I say AI, I'm using it, implementing it, and designing it. So after this talk, also I'm involved in that. So when it comes to AI, there are different areas. For example, the design areas, UST works with the experts. When I say experts like Cadence and Mental Graphics and all those, they have their own plugins. Okay, say Synopsys, so you can use their extensions. When it comes to manufacturing, there are different companies like Advantage, Teradyne, and all that. So as of now, complete automation is still not feasible because semiconductor industry is not like other industry because every point is like very crucial and it's like $1 million decision. So currently AI has been like more of a assistant perspective. So in the past, let's say if in a factory, if you have to find out some root cause, a person has to manually write in Word and all that. Now, if you have a knowledge base with the AI tools, we are able to easily generate those documentations so the production flows happen very fast. And there is some smart factory automation. And when it comes to design the correlation reports or graph analysis, So it has been very helpful in that perspective. Now there is a demand similar to other sector to embrace agentic AI, and which is basically tool calling. So you can imagine when you're using EDA tools, there are some macros. So you would have tool calling LLMs to call the relevant tool based on what you want. So let's say I want to compare two corners, then it should able to call the relevant macro, run it, and then finally generate the chart. Yeah.
Okay, good.
Mm.
So there will be last question. So is ATE program
Mhm.
development knowledge transferable? So as for example, from Advantage to Teradyne or NI platform.
Yes. For your question, the answer is yes. But if you still get some exposure, it's good. It's like this, for example, let's say you're good in Microsoft Word, PowerPoint, and Excel. Is your skill transferable to Google Word and Google Doc and Google Cal? Yes. Yeah, as long as you understand they are just tools. If you focus more on what is a spreadsheet, the concept of calling a formula and spreadsheet, and Word documentation, how do you generate the table of contents, it's transferable. In the same way, when you're in Advantest, focus on the fundamentals first. And of course, then next come to the tooling. So when you do that, moving from one platform to another platform would be easier.
Okay, nice. So I guess that's all for the questions.
Yeah. Any question missed or anything else?
Mm, yes, we still have since our timing is already.
Yeah.
Yeah.
Okay.
It's not yet. Okay, there is more questions.
Sure.
Sorry,
Sure.
sorry, my bad.
Sure.
So what is very large scale integration?
Oh, I think this is it's like a
Yeah,
Google
yeah, yeah.
it's like a Google question, I believe. Yeah.
Mm.
So yeah, it's an acronym, but it's a traditional acronym. It typically refers to the technology how we shrink complex circuit in a very small space. So there is a complete history of it. So in the past, when we realized the circuit, it used to be those large, thick vacuum tubes, and Shockley came with this discovery of transistor, and then there is BJT, then there is CMOS transistors. So there is a series of technology where every few years we manage to get more things done in a short space with less power. So yeah, so the acronym refers to VLSI, very large scale integrated circuits. So yeah, so it's a large scale circuit, but it is still integrated in a smaller span. Yeah.
Okay, another one. Any use case in AI chips for business in Malaysia?
Any use case?
Any use case in AI chips for business in Malaysia?
Okay, so currently it happens to be with the standard chips. For example, UST we are vendor neutral. We work with Nvidia, we work with AMD, we work with Qualcomm, and when we say chips, it depends on the load. For example, there is this cloud AI to on-prem and edge AI migration. That's what I work. So basically, understanding the load and transferring it to on-prem, like how much stops it is, and identifying which rack or desktop or chip it is the most suitable depending upon the power requirement or the budget as well as what is available here. So that's where maybe you shift from say from Amazon or Alibaba or SNS or maybe Whittier or something, and they would want say on-prem. Then we decide which on-prem can realistically do. So then you decide is it Intel or AMD or Nvidia or Qualcomm. So that's on-prem. Similarly, there is something called Edge. So Edge is basically is much more simpler, like the Raspberry Pi kind, right? So there again, you further shrink it down and remove the layers, and there you come whether it is Raspberry Pi or Arduino or ESP32. Yeah. So in Malaysia, when it comes to business perspective, we are working with healthcare, clinical LLM development projects, and as well as in the palm industry. Basically, you do AI for grading if a palm is ripe or unripe, or the FOP grading, as well as semiconductor, of course, is the main industry. So that's where, as I explained you, semiconductor in every phase, right from start to the end, even recruitment also. We have AI solutions within UST to make sure your resume is properly scored and verified and properly goes to the respective technical team. Yeah. So these are some of the use cases that I've explained you. And yeah.
Okay. There is also a question from Santosh Mokashi. What UST is working on AI workload hardware?
what UST is working on AI workload hardware. So as I said, we are not a chip manufacturing company, UST. So we have our engineers working in all these AI companies as well. And when you say UST working on AI workload hardware, as I said, we are solutioning. So we are vendor neutral. So we know how to do the end-to-end solutioning. So for example, if when I said the palm, so it's end to end. So right from the digital integration, right from conveyor belt, what should be the camera, what should be the chip, and what should be the model? Is it CNN, the kind of grading model? Yeah. So we work on the solutioning perspective. So yeah.
Okay, another one is will Perl be eliminated? Will Perl be eliminated since more and more companies use Python nowadays?
I think it will take time. Of course, Python is capturing most of the areas, but compared to other industries, healthcare, semiconductor, they are, but there are a lot of rules and complaints. It will not move so fast. We can't break things. In other areas, it's like you break and move ahead. So it will take time. But it's always good to learn Python. Python is essential. Some of the enterprise still have Perl, and we still can't move just like that. Yeah.
Okay, another one. If someone is designing a chip for hardware security using Vivado software,
Mm.
it is enough for learning the chip design process?
I think, as I said, no, we should not give more importance to the chip or the tooling software alone. The underlying principle of the chip design process is something is very important. So I think we should focus more on that. Yeah.
Okay. So this is the last one that we have now. How does UST uses AI for the design workflow?
So we work with our partners, as I said, the chip design companies, because our engineers are using their software in client place as well as within our solutioning. And these companies have good enough generative AI plugins. And traditional AI has always been there. So when we say AI, right, nowadays everywhere they say AI, but at the overall two types is there, the traditional AI, which is more deterministic and highly accurate, like more of you know like a machine learning kind. The generative AI is also machine learning, but it's more interactive. But we still haven't reached a state which is very much accurate. So we use the traditional AI for simulation for higher accuracy applications. We use generative AI when it comes to assistant kind of applications.
Okay. There is someone also asked what is Python.
So Python is not a snake here we are referring to. So there are different programming languages, and Python is one such language. It is an open source language, and it's like a generic language. That's the reason it's more popular. It's like Microsoft Excel sheet where HR can use, engineers can use, anyone can use Excel sheet, right? So in the same way, Python, it depends on how the engineer who is using, right? From circuit designers, test program or AI, everyone can use Python. So it's a easily understandable language.
I think that's all for the questions from the chat box.
Yes. So how students should be familiar with?
Wait. Oh, there's another one just now. How as students should we familiar ourselves with working with AI?
Yeah, so it's a very good question. So you can imagine AI is like how computers came for the first time. When we went to college, computer was like, oh, it's a big thing because we used to carry this large tape drive. I'm not sure many people even know, even before floppy disk. So in the same way, you are entering into a phase. The AI is going everywhere. So have daily touch with AI. When we say AI, you read about it, use the tools, and like how most of you would have used ChatGPT, Gemini, and things like that. So in the same way, there are multiple AI tools online you can search for learning this chip design. Like a simple way, let's say you want to generate some Verilog code for inverter and all that, you can just put it in the prompt and you get it. So get exposed to that. Yeah.
Okay, there is another one as well. Is VLSI important to work with embedded system?
Mm. The knowledge of VLSI is still required for embedded system. You don't need to be knowing in depth like a designer, but of course it is essential because when you say embedded, you're referring to the chips, so you still need to know.
Hmm. Okay, this one from Lee Won Cheng. Will like Linux environment better to learn embedded system compared to Windows environment?
Yes, I agree. So I would say, I think Windows is something everyone can use, right? You even if it's very self-explanatory, and has become like very essential. But if you're planning your career on electronics, VLSI, design, AI, everything, Linux is very important. Make sure you know you use Linux. Yeah, so Linux is very essential, I would say. Whether it is semiconductor or AI, Linux is essential.
Hmm.
Yeah.
Yeah, I think that's all from the chat box. If
Yeah.
you have any questions, can drop the questions
Mm.
from the chat box.
I think in chat box there is a Windows versus Linux war. So I'm using now Windows, of course, but I'm saying Linux is essential. So that skill is very important.
Hmm. Okay, we got a new one. Is
Mhm.
problem solving skill important beyond interview?
Yes, yes.
Hmm.
So for all other things we have AI. We still need human beings who can solve problems. Yeah. So there are some mental models. You can maybe who is interested, you can search for mental models for problem solving. There are things like first principle or apple to apple comparison, and there are different ways how we can solve a problem. So you can apply.
Okay. There is a new one as well from Muhammad Ifran. What Linux distros are commonly used in this industry?
Okay, so it's a very wide industry. But since I am assuming we are talking focused on IC design, if it is IC design, typically they go for very robust enterprise Linux distros like Red Hat and SUSE Linux. And other areas, if it is AI for just the prototype perspective, they go with Ubuntu. Yeah.
Okay, another one. What code editor for embedded system does UST use?
That's also a very wide question.
Hmm.
For now, most of them just go with Visual Studio Code because it has some universal plugins.
Hmm. Okay, I think that's all from the chat box.
Yeah.
Okay, there is a new one as well. Can I get fabricated IC from my academic layout design at free of cost?
So this one, there is this thing called test vehicle. Recently, I saw for the past 2 quarters, there are foundries who can fabricate for you free of cost. Most of them are in US, I believe. So you can search open source free fabrication IC. You can have a look at it. So where students can submit your design, and if your design is good and all that, they can fabricate and they can even arrange shipment. Yeah, you can have a look at it.
Hmm. Okay, there is a new one. Do you use two different laptops for both OS or you use dual boot for Windows and Linux?
So at work, when you are working with our clients, it will be very high powerful Linux servers. So typically we connect it remotely through SSH. That is, you still have Windows laptop, but like how I'm connecting to the Zoom meeting, right? So in full screen, it will go to that Linux environment. Most of the time, Linux environment is command based. There is no GUI. The reason Linux is it's very powerful. You can control every process and all that. So personally, in my laptop, not in work, in my laptop, what I do is I use this Windows subsystem Linux, where I can have a Linux that can run on top of Windows. That is good enough for my experimentation.
Okay, the next one is what topics from VLSI are most important to get in industry?
As I said, fundamentals. Just focus on the fundamentals. And industry is very wide. There are a lot of opportunities, and yeah, focus on the fundamentals.
Hmm. The last one from Amirul Danish. Is it advisable to use VMware?
Um, it's actually some industries use, but at a personal level, there are many options other than VMware. If it is industry, yes, VMware is definitely powerful. If you want to learn at a personal level for OS loading, you can go with WSL like Windows Subsystem Linux if you are using Windows. And yeah, there are many other options also similar to VMware.
Okay, this is one is a long questions.
Mm.
As a year 4 mechatronics undergraduate student, I would like to ask whether if a mechatronics student also take additional subjects such as VLSI and do very lot projects using FPGA, is it any chance to enter the semicon industry, even if I have a fewer chance to explore EDA too?
Uh, it all depends on your passion and interest.
Mm.
So I have seen people who have done like chemical engineering and they have been doing very good in IC design also. It depends on the passion. Of course, a person from electronics background can easily learn. For mechatronics, you have to put some extra effort. So it depends on how much passionate you are. Yeah. So like for example, you'd find someone is a cook, but he has some ability to sing and they show the talent and their life changes, right? So the same way, although you're from mechatronics, as long as you can show it, not just by learning with some projects and all that, then industry wouldn't mind.
Okay, another one. How to choose appropriate PDK for IC fabrication?
So for that, for example, the one that I referred to, the free fabrication. So some universities, they have open source their traditional PDKs that you can use for learning. If you are referring to the PDKs within industry, that goes through a lot of decision making in the company based on what is the PDK that is currently having good roadmap in the industry. So if, for example, so if it is TSMC, then they will have some decision making for the 5 years and for the market requirement and all that, they'll choose a PDK.
Okay, there's a one. Wait a second. Do you need advanced understanding in Linux or basic understanding is enough to survive?
Again, the more the better. Something is better than nothing, I would say. Yeah. Yeah. The aim is not to become the Linux expert, but the aim is to make sure you know good enough Linux. Yeah.
So there's another one. What advice will you give to those who have zero knowledge about Python but eager to learn?
Just learn. And nowadays with AI, I don't think people are looking like you memorize all the syntax, right? Any program, let's say what I learned in 5 years now, I think AI gives in 5 minutes. So you can make use of AI to generate a code and all that, but you still need to understand how to run the code and compile and all that. So you get started, just like swimming. So someday you have to fall in the water and try.
Hmm. Okay, there is a new one. What type of microcontroller board is usually used in industry workplace?
Okay, so that is something I have another team who focuses more on a IoT microcontroller perspective. Recently, I believe the ESP32 project is where UST was looking at here.
Okay. I think that one is the last one, but is there anyone want to? Oh, there's a new one. Prefer bare metal code or work with HAL?
What is HAL here we are referring to? I need to know the acronym.
HAL, HAL.
And before that, there's a question from experience. You've got knowledge on C++, Java, can integrate on
Oh,
Python. I think it's just an opinion, I think.
yeah.
Ah, is assembly language often used in the industry in STM32? Yes, it is still used in very, what to say, low latency kind of requirement.
Mhm.
Yeah, it is still used. Yeah.
So last question, what kind of portfolio or project needed to transfer from computer science background?
Again, you show that you have that knowledge. I think the industry wouldn't mind if you're from computer science or mechatronics. So whatever area, so it's like an ocean, right? You pick some area. Let's say you want to show that you're good in digital electronics. Maybe do some project and put it in GitHub or Kaggle or whatever, Yeah. Or let's say you want to focus on DFT, then do some example projects.
Okay, I think that's all for the question chat box
Yeah. Okay.
session.
Thank you.
Okay, thank you, Mr. Kota, for the
Thank
great
you.
sharing. So if you guys have any question, you can just drop in the chat box and then later maybe Mr. Kota can reply you in the chat box.
Yeah.
Okay, thank you so much, Mr. Kota
Thank you.
Barusha, for great
Thank you
sharing.
very much. Thank you. Bye.
So, all right, everyone. We are now moving into the next exciting segment, which is the immediate action final and mini aptitude test session. So this session is intended to help assess your understanding and readiness following today's program. Please note that this is not an examination, but an opportunity for you to evaluate your potentials and next learning pathway in the semiconductor field. If you already answered this test yesterday's session, you don't need to take it again because it's one-time test. So this test is only a guide and reflect your current interests. So just answer honestly based on what suits your best. So let's answer the test. You can have your time to answer.